Hello, my name is Gary, and I'm with Hoffmann Machine Company. Today I'd like to introduce you to our new face frame combination system. Beaded face frames were once only used in high-end cabinetry, but we now see more and more of them in mid-level custom kitchens and even some commercial work. With our system, you're able to produce beaded as well as standard face frames quickly and accurately. We have integrated 3 pieces of equipment: an automated length stop system, a precision cutoff saw, and a beaded face frame notching machine. All 3 of these machines are locked together with a heavy steel frame. This will assure long-term accuracy. In this video, we will show you how each of the individual machines work and how they will work together. The automatic stop system is made by Technical Services Inc., the designers of RazorGage. We offer machine packages with 8-foot or 10-foot stops, and we can also supply longer or shorter lengths if needed. The RazorGage systems distinguish themselves from the other stop systems on the market by paying close attention to the critical details. Instead of relying on plastic or steel wear strips, they utilize THK linear bearings and steel rails for the carriage travel. Also, they use larger zero clearance pulleys with planetary gears, and each RazorGage is laser inspected for accuracy prior to leaving the factory. Precise and accurate cuts are critical for tight-fitting joints and perfectly square face frames. The cutoff saw is a production model made by Omega Woodworking Machinery, and it has proven itself in thousands of woodworking shops around the world. The machine is a heavy cast iron base and is a belt drive design, 2 features that reduce vibration and improve the quality of cuts. The 14-inch blade gives us a maximum cutting width of 6 3/4 inches at a 90-degree angle. This covers the vast majority of face frame stiles and rails. MORSO notching machines have been used around the country and around the world since 1911. We've been the U.S. importer for over 10 years. The company makes both manual and automatic models and are all available from stock. For this video, we've installed the foot-operated NFXL model. This machine accepts molding up to 6 inches thick and 8 inches wide. All hard and softwoods can be processed with ease. In fact, we have customers building the face frames with soft pine and cypress, and on the other end of the spectrum with rock maple, teak, and even epay. To design a face frame right on the screen, open the face frame builder, then click on New Frame. And for our example of a vanity base, enter the overall height of 36 inches and the width of 30 inches. Depending on the cabinet, a top rail might be wider to allow for crown molding, or a stile may be extra wide for scribing. The software is designed to accommodate varying widths of stile and rail. In our example, we're using a 2-inch top rail, a 4-inch bottom rail, and 2-inch wide left and right stiles. With the perimeter parts selected, press OK, and the basic frame is now displayed on the screen. To add a cross rail between a drawer and a door opening, select Rail, enter the clear dimension between the upper rail and the new cross rail. In our example, we are using 6 inches. To add a vertical divider, click on Style. If you want it centered, click on this box. The program will do the rest. When all the parts are added, click on the Save Frame, give the frame a name, and save it on the PC. Now click on Make List. This will format the entered data into a cut list, which is also displayed on the screen. The designing portion is now complete. The next step is the machining process. Open the RazorGage software, select Auto List, and click on a file name. A detailed list of all parts needed for the selected frame is now displayed. Select the first piece and the razor gauge will automatically move into position. After cutting the part to length, click Part Cut. If there are multiple parts to be cut, the program counts down the total and draws a line through the description after the last piece is cut. When all the pieces are cut to length, the stiles and rails are now processed on the MORSO notching machine. On the main screen, select Notching. Highlight the file name to see a list of all parts needed for that particular frame. Select the part displayed on the screen, with all required notch cuts highlighted. Place the molding on the machine table and click on the screen to advance the stop system to the first notching location. Holding the molding with the left hand, the cutting head is moved toward the beaded edge with a hand lever, and stepping on the foot pedal brings the head down. Multiple passes are needed for clean and tear-free cuts. Depending on the wood species, it usually takes from 2 to 4 cuts to notch a bead. When the rail is finished, it is set aside and the next piece is processed. The knives are designed to stay sharp for a long time. In custom woodworking shops, we frequently see them used for over a year before they are sent back to us for resharpening. We have the equipment necessary to regrind and hone the knives to factory specs, and we generally return them to the customer in just a few days. Here we are doing a quick demo on the MORSO NFXL. The stile is placed face up on the table, and multiple steps will assure a clean notch. The adjustable stops next to the head are set to limit the travel of the cutting head. These are adjusted to match your bead. You can easily cope the end of the rails in one single pass. After the stile is notched and the rail is coped, you'll have a tight, perfectly aligned joint and are now ready to go to the next step. Notching machines are available in the manual version as you have just seen, or electro-hydraulic for higher productions. Once all of the components of a face frame are finished, the frame is assembled using the Hoffmann dovetail joining system. We have set up our PU2 floor model routing machine for this operation. The fixtures on the machine locate the notched molding precisely above the router bit, and the square stop is used to reference the location of the coped rail. Once the keyways are routed, some glue, the dovetail keys, and a hammer is all that's needed to assemble the frame. No assembly tables, presses, or clamps are needed to complete the frames. This completes this portion of the video on our face frame combination system. Thank you for your time. We look forward to hearing from you soon.
Cutting the notch positions in stiles using the MORSO NFL. Place the workpiece on the table and start by cutting the corner first. By moving the profile, nibble in stages until it reaches the stop. Flip the stop back, move the workpiece to the second stop by using the hand lever. Make 2 or more stage cuts as required to make the second notch. Move the workpiece beyond its final position and trim the corner. To start the final notch cut, set the flip stop in its final position and finish the final notch. The first stile is now complete. The second stile, opposite hand, is processed in exactly the same way. To cope all the corners, release the center stop, move it forward and then retighten. Position the ends of the top rail against the stop and cope the corners of the beaded edge left and right. Position the center rail against the stop and cope all the corners. Position the bottom rail against the stop and cope the corners. The frame is now fully notched. Cutting the notch positions in stiles using the MORSO NLEH. Place the workpiece on the table and start by cutting the corner first. By moving the profile, nibble in stages until it reaches the stop. Flip the stop back, move the workpiece to the second stop and using the 2 hand buttons actuate the machine to make 2 stage cuts to make the second notch. Move the workpiece beyond its final position and trim the corner. To start the final cut, set the flip stop in its final position and finish the final notch. The first stile is now complete. The second stile, opposite hand, is processed in exactly the same way. To cope all the corners, release the center stop, move it forward and then retighten. Position the ends of the top rail against the stop and cope the corners of the beaded edge left and right. Position the center rail against the stop and cope all the corners. Position the bottom rail against the stop and cope the corners. The frame is now fully notched. The notches have already been processed on the MORSO guillotine. We must now router the dovetail slots in the profiles using the Hoffmann dovetail routing machine. Using the center fence and packing piece, lay the first stile in position and lower the clamping unit to the workpiece. Start the routing process using the foot pedal and router the first dovetail slot. Move the workpiece to the next notch position and repeat the process for all notch positions. The second stile, opposite hand, is processed in exactly the same way with Hoffmann dovetail routed slots. We then change over the fence system to accept the cross rails. Remove the centre fence and replace with the sliding stops against the set screws. We can now process the cross rails. The simple rule to follow is that a beaded edge is always laid against the sliding stop. The foot pedal is pressed to actuate the routing process. Slide the stops to the right hand side of the machine and process the other end of the rails. Centre rails, which are double beaded, can be processed without sliding the stops to the other side. The complete frame is now processed, ready for assembly. To complete the assembly, glue is applied to the mating surfaces, and Hoffmann dovetail keys are inserted to draw the joints together. In production, a complete frame can be notched, routed and assembled in approximately 4 minutes per frame.
Hi, I'm Steve Hosher with Technical Services Incorporated, and I help create the RazorGage line of saw stops and measuring tables. We at Technical Services RazorGage developed this video to provide you with a better understanding of precision linear positioning and to demonstrate the benefits RazorGage has to offer. Our RazorGage products are designed around the following design criteria: reliable long-term accuracy, ease of installation, maintenance, and repair, open control architecture, and choice. Reliable long-term accuracy to us means to minimize the likelihood of your producing a bad part ever. Not just for the first 3 months or the first 3 years. Our goal is to provide a positioning system that goes to the right place all the time, period. In order to explain the steps we take to attain reliable long-term accuracy, let's take a look at how motion control technology works. A typical linear actuator includes a controller and drive, motor, mechanical drive system, support bearing, and an encoder mounted to the rear of the motor. The controller and drive make the drive shaft rotate. The drive mechanism converts the shaft rotation into linear motion. The support bearings maintain the orientation of the carriage as it moves. The controller verifies the commanded motor position by keeping a running count of the pulses returned by the encoder. Equations in the controller convert these pulses into theoretical linear position. Since the controller only knows the position of the encoder, the challenge on this type of system is to try to make sure that if the stop moves, the encoder moves. Controlling play in the carriage support bearing is the first step in keeping stop position in sync with the encoder. It's the job of the carriage support bearing to maintain the orientation of the carriage as it slides down the rail. If the carriage support is sloppy, then the stop position can change. For the RazorGage carriage support bearing, we've chosen a machine tool grade recirculating ball bearing block riding on a hardened and ground steel rail. The balls in the bearing block are selected to provide a negative clearance condition or preload to eliminate slop. A tight-fitting seal keeps sawdust out and lubrication in. This style of bearing assembly is rated for over 3,000 pounds radial static load and has a long history of successful application in high-end machine tools and woodworking equipment. There are no gibs or pads to adjust. Just grease the block a few times a year and this bearing will be rigid for years. Eliminating stop in the carriage support is easy. You just find the best bearing on the market and buy it. But there are a number of components between the carriage and encoder that can introduce lash into the system. We approach mechanical lash in the drive system differently on the different RazorGage models. On any rotary encoder system, long-term accuracy depends on the integrity of the drive components. For RazorGages using a belt drive, we use a high-test polyurethane belt reinforced with steel cables to resist stretching. We use a zero-clearance drive pulley to eliminate the play inherent to standard belt and pulley combinations, and we drive that with a precision planetary gearhead with near-zero backlash. To top it off, we calibrate each unit with a laser displacement meter before shipping so we know it's accurate before it leaves our plant. While we offer the RazorGage with rotary encoder feedback, we do so knowing that one day something as insignificant as a loose set screw, a washed out keyway, or imperfect belt tension can completely undermine our desire to provide reliable accuracy. That's why we pride ourselves on manufacturing the ultimate programmable saw stop, our top-of-the-line linear encoder models. By eliminating the rotary encoder from the back of the motor and instead using a linear tape encoder that runs the length of the table, we completely eliminate all problems associated with mechanical lash. The linear encoder ensures that no matter what condition our drive system is in, the controller still gets accurate positional feedback. The non-contact operation and solid-state design of the linear encoder makes it a long-life device, and since it's magnetic and not optical, a dusty environment doesn't affect the operation. As we all know, any device can fail, so as further assurance that you make only good parts, we provide an on-target lamp on all motor-driven RazorGages. If some problem develops with the linear encoder, such as a crushed cable or a loose connector, the erroneous signal will cause the lamp to flicker or not come on at all. But when the lamp is on steady, the chances are very slight that you can make a bad part. This light is wired in series with a relay so you can lock out the saw when the stop is not in position. These and other measures enable the screwdriver RazorGage to achieve plus or minus 0.03 of an inch accuracy over 10 feet. To back up our claims, we laser check every linear encoder RazorGage before we ship it, and we put the charted results in the manual so you can be sure your product meets RazorGage standards. We believe we make the most accurate and reliable stop on the market, but when components fail, we make them easy to service by incorporating this removable guard. 4 screws secure the removable back guard panel that, when removed, allows access to the entire inside of the RazorGage. Electrical components are easily accessed in the eye-height mounted electrical enclosure. All our parts are standard catalog items that can be bought from local distributors. We make the RazorGage more flexible by using an open control architecture. That just means we use products that can be customized and serviced by your own people or by someone in your local area. Our controller is programmable and expandable with software, manuals, and programming examples that can be downloaded from the manufacturer's website. You don't need to come to us if you want to change. We provide you with a truly easy way to download cut lists over your PC network, our CE option. A color touchscreen PC running Microsoft Windows CE replaces the standard keypad. It supports Ethernet communications, barcode readers, and an optional printer port, and enables the RazorGage operator to download cut lists from a PC on your existing Ethernet network. You just paste your data into an Excel spreadsheet, save it, and it's available to the RazorGage operator on the manufacturing floor. For applications requiring a full-blown PC, we offer the PC option. It includes a color touchscreen panel PC running a Microsoft Windows operating system. The last benefit on our list is choice. We designed the RazorGage to be configurable in several ways. For the highest accuracy applications, we offer the screw-driven RazorGage with linear encoder. It's accurate to plus or minus 0.03 of an inch over 10 feet and is available in 48-inch, 96-inch, and 138-inch lengths. For applications not as demanding, we offer our belt drive system with linear encoder. It is accurate to plus or minus 0.05 of an inch over 10 feet, is available in strokes from 24 inches up to 22 feet, and can be motor-driven or hand-wheel driven. The hand-wheel drive unit is great if you want the RazorGage performance at an unbeatable price. We also offer all the belt-driven RazorGages with rotary encoders if you can live with tolerances in the plus or minus 0.15 of an inch range. If you just want to measure parts, we offer the RazorGage caliper measuring table. You just put the part on the table, push it against the hard stop, and measure it. Well, we've talked about the 4 major benefits we strive to provide as we design the RazorGage and the means by which the RazorGage achieves them. Reliable long-term accuracy. We use machine tool grade linear bearings to maintain carriage orientation and minimize lash on our rotary encoder systems, and eliminate the harmful effects of lash with the linear encoder on our high-end systems. Ease of installation. Our integral table and fence, removable back guard, and easily accessible electrical enclosure make the RazorGage easier to install and maintain. Open control architecture. We use off-the-shelf programmable components and offer solutions running Microsoft Windows so you can download cut lists using standard Ethernet and Microsoft Excel, or can hire local experts to develop custom applications. Choice. RazorGage is available in models designed to meet the demands of your application. The hand-wheel drive unit, the motorized belt drive with rotary encoder, and the top-of-the-line linear encoder actuators. I hope you found this presentation helpful, and I hope our design goals are consistent with and will help further the goals you've set for your shop. If you have further questions or would like to schedule a demo, give us a call at 515-232-3188. We'll do our best to get something set up. Thanks for your time, and remember, when length matters, use RazorGage.